Hey guys, so we're going to take a look at 6 different types of synovial joints really quick. So this is not to be confused with types of joints like synarthrodial, diarthrodial, fibrous, cartilaginous. These are 6 different types of synovial joints. So synovial joints mean that they have a joint cavity, and that typically they're pretty mobile, although that's not always the case, especially for this first one here, which is called a plane joint. A plane joint is, I guess, what it sounds like. It's just two relatively flat or curved congruent surfaces. Um, two different bones, the two different bony partners slide over one another. And there can be some rotation, there can be sliding. And this little icon here is kind of showing you the potential different motions. Now, this image is referring to a plane joint as either being biaxial or triaxial, depending on how it can move. Um, I guess I'm okay with that. I typically though, plane joints are described as being non-axial. Now, in the case of rotation, I definitely think you could make an argument for them being uniaxial, but let's just keep it simple. Let's go with what your textbook and then just what I'm used to hearing. Let's call these types of joints non-axial because typically they aren't rotating around an axis. Um, Now let's look at our hinge joint, which is just the textbook definition of a uniaxial joint, and that's right here, this top right image. So they're drawing kind of a stick figure version of a hinge joint here, and you see this convex um, joint partner and then a concave joint partner, and the concave partner is rotating around the convex partner. And a great example, which almost looks identical to the stick figure drawing, is the elbow, specifically the ulnohumeral joint. So the ulnohumeral joint can flex and it can extend in the sagittal plane around a medial lateral axis. That makes it a uniaxial joint. And that's true for all hinge joints. It's uniaxial. There are, however, a couple modified hinge joints like your TMJ and your knee, your tibiofemoral joint, because they flex and extend. In the case of your mouth, they open and close. But they can also do some rotation, some gliding. Um, we call it a modified hinge joint. That's not a real joint type, it's just a phrase that gets used. So if I ask you for an example of a hinge joint, go with the ulnohumeral joint. I may also ask you how many axes does it have, or whether it's uniaxial or biaxial. It is uniaxial. Another uniaxial joint is called a pivot joint, which is right here. You can see the head of the radius uh, articulating with the radial notch on the ulna. And so this joint is going to be involved in pronation and supination of your forearm. It's uniaxial because it can only do two motions, and those two motions are both around the same axis. So pronation and supination are around a superior-inferior axis in the transverse plane. So that's the pivot joint. Another example of a pivot joint would be your atlantoaxial joint, which is the joint between the dens of C2 and the facet for dens on C1. So when you shake your head no, that's the joint you're using to do so. That's another pivot joint, another uniaxial joint. Now things start to get a little bit more exciting. We have our first biaxial joint, and it's a condyloid or condylar joint. So your wrist is two condyloid joints. I'm used to the word condylar and I like it better, so I'm sticking with it. Um, Another example of condylar joints are your knuckles or your metacarpophalangeal joints. So when you make a fist, you are flexing your MCPs, your metacarpophalangeal joints, and then when you stick all your fingers out, you're extending them. But that's not the only thing you can do with your knuckles. You can also abduct and adduct them if you open your hand up and then bring your fingers together. Or is it Star Trek. This makes me sound like a nerd. I'm not actually, well, I am a nerd, but I'm not actually a big Star Trek fan. But It's just perfect, a perfect analogy, where the one guy spreads his middle and index finger, he puts his middle and index finger together and his ring and pinky finger together and then spreads them out and makes a V. That's an example of abduction. Or a peace sign. Let's say you're making scissors with your index and ring finger and you're pretending to cut paper. When you bring your fingers together, that's adduction of your MCPs. And then when you open them up and make like a peace sign, that's abduction. So that's the same joint doing 4 different motions: flexion, extension, abduction, and adduction. So it's doing 4 motions, but they're in pairs because flexion and extension are both in the sagittal plane around a medial-lateral axis, and abduction and adduction are around an anterior-posterior axis. So all of that to say, a condylar joint is biaxial. So I may ask you for an example of a condylar joint. I may ask you how many axes does it perform. I don't think I'll give you a specific example and ask you to name the motions. That's a little, I think, too much for this class, but definitely know how many axes and know an example. An example from this video. And then the next one is a super interesting one. It's called a saddle joint. And in class, what I always do to try to explain what a saddle joint is I ask people to remember Pringles chips. Does anybody remember Pringles? I think they're still out there. They had all those weird commercials. They're the tube of chips that fit on top of each other, and their slogan was, once you pop, the fun don't stop. Anyway, so those chips, they sat on top of each other in this weird way. I'm used to having my hands to explain this to you, but they kind of in one plane, let's say the frontal plane, they were convex superiorly, right? And then in the sagittal plane, they were concave. And so they just had this weird shape, and they looked like a saddle, which is why it's called a saddle joint. They looked like a saddle, and they fit on top of each other. So picture 2 saddles, and there's a great picture right here. But picture 2 saddles kind of sitting on top of one another, and you can imagine how they could, in this case it's our thumb, you could imagine how you could flex your thumb, extend your thumb, abduct your thumb, or adduct your thumb. And this is a carpal metacarpal joint. So it's at the base of your thumb. Anyway, that's called a saddle joint. It's the only example of a saddle joint in your body. It is a biaxial joint. Arthritis is somewhat likely in this joint because we kind of tend to treat it like a ball and socket joint, and do circumduction with it and that kind of a thing because we can. It allows for that, but really it's we're just kind of combining its 2 axes in a weird way that probably isn't that good for it. Anyway, I digress, but the point is it's biaxial, and like the condylar joint, it can produce 4 movements around 2 different axes. And then lastly, we have the ball and socket joint, which they call triaxial. We don't really use triaxial because, well, I don't know exactly why, but I think it's because, yes, it's around 3 axes, but there's certain motions like circumduction that involve any number of axes, and not to mention multiple motions that can occur around 1 axis, like horizontal abduction and adduction both occur around a superior inferior axis, but internal rotation and external rotation occur around that same axis. So for whatever reason, we tend to call them multi-axial joints. And we only have 2 examples. They're both ball and socket joints, and it's your shoulder and your hip. And as you guys know from the lecture, these are some pretty remarkable joints. They can perform flexion, extension, abduction, adduction, horizontal abduction, circumduction, internal rotation, external rotation, all kinds of different stuff. So that's why we call them multi-axial. And I think that's it for this video, guys. Just shoot me a message on Canvas if you have any questions. Thanks.